Hi there, algebra students. Mr. Rising here once again, and this is lecture 6.3 in your algebra textbook. And remember, as I'm doing these lectures, please feel free to follow along in your book. You can pause them, you can go back to them, you can speed them up. If you're just better off with the book, use the book. Again, you can use online resources as well. They're on the page. I got my dog Stacy here. We're going to do several lectures today. It's a Sunday morning here in Seward. Really pretty chilly in the room, so I got my cup of coffee, but we're going to bust this out. So 6.3 is all about classifying and evaluating polynomials and what that means. Oh, okay, Stephen. It's okay. All right, we're back. There we go. So let's get started. I'm going to try to keep these videos to 7-8 minutes or less. Following along in the book, some vocabulary. Good things to know. A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. So for example, the exponent here, right, is, well, in a constant, it's 0. Let me go back to this in a second, but 0 is a whole number. X, of course, is to the first. Here's an x and a y. Those are both to the first power. Here's to the fourth power. So these are all monomials. Things that are not monomials, to the negative second. Here you've got two variables being added together, so those are different. This would be like the negative third power, so those are not monomials. I mentioned this too. The degree of a monomial is the sum of the exponents. So for example, to the first, the degree is to the first. The degree of this one is to the fourth. The degree of this one would be to the 1 plus 1, or the second. Now it says a constant has a degree of 0. Here's why. Imagine if there was a variable attached to this 5. It would be like 5x. But where's the x? Well, the x is to the 0 power. Boom! That's why anything to the 0 power is 1, so it's basically inconsequential. Anyway, that's sort of the math theory behind it. So when it gives you these examples such as find the degree, what it means to do is to add the exponents together. Even though you're not combining them, they're just saying count the number of terms, not terms, the powers added. So for example, this first example, p is to the fourth, q is to the third, so that's to the 7th degree. This one, there's e to the first, d to the first, second degree. A constant, just the number 3. Imagine there's a variable there, but it's to the 0 power. And again, you get lots of other examples here. For example, this one, k squared m. Of course, that would be to the third. This one, there's just x to the first. And then this one here is to the third. And there's your example that go with it. Again, pause it if I'm going too fast. I totally get it. So polynomials are monomials that are added or subtracted. They're combined. And the degree, poor Stacy, the degree is the greatest, is the term with the greatest degree. And here's what I'm talking about. For example, this is 11x to the 7th plus 3x to the 3rd. It is definitely a polynomial. Since x to the 7th is a greater power than x to the 3rd, the degree is 7, right? In example B, you can see you've got w2z, so that would be the 3rd degree. Z to the 4th is the 4th degree. Minus 5 is the 0 degree, therefore the highest degree is 4th degree. And actually this matters because this foundation will determine the shape and the picture and the pattern of functions throughout your mathematical career. So again, on this first example, let's see, 5x minus 6. I've got x to the first. The degree is the first degree, or degree 1. When I look at these, let's see, I've got x to the third, y to the second. That's 5th degree. I've got x to the second, y to the third. That's 5th degree. I've got x to the 4th degree. 2 is to the 0. Therefore, the highest is the 5th degree. And again, if I'm going too fast, slow me down. If I'm going too slow, speed me up. And again, here's some more examples. We're gonna actually practice this in class. So that's what we're trying to do. Now, when we write equations, we try to write them in standard form, and it is a way to communicate across all languages, all worlds in mathematics. And how we do that is we have the highest degreed term, monomial, goes first, okay? And the number in front of that monomial is called a leading coefficient. All right, so again, you can pause this and read this. And again, I'm following along in your book. But here's what I'm talking about. When I have this, this crazy looking polynomial here, what I need to do is really reorder it, number one. Now, I'm actually looking at each monomial and I'm determining the degree. All right, first, fifth, second, 0. Now I write them in order, highest degree first. So you'll notice the negative 7x to the fifth goes first, followed by the 4x squared, the 6x, and then the 9. So I've gone in degrees 5, 2, 1, 0, putting them in order from highest to lowest. The leading coefficient means what is the number in front of the variable of the leading term, and it's negative 7. So when I look at this, it's saying, hey, that negative 7 actually has a lot of value as we go into Algebra 2 and beyond, because it's going to determine the shape and general direction of the equation you're trying to graph. I see I'm approaching 6 minutes here. Just remember, when you have something like y to the fifth, there is a 1 in front of it. So the leading coefficient of just a variable raised to a power is always 1. Just a couple more examples here, and I think we're almost wrapped up. And again, here it says write the polynomial in standard form. Again, it looks like I've got an x to the fifth as the highest power. Oh, hello. Let me just go like that. Bam. And so that means it's going to go first. The leading coefficient of that x to the fifth is 1. And then I work my way down in order. 9x to the third minus 4x squared plus 16. And I think as you start to practice these things, you'll really see it. These degrees really are significant, and the number of terms are significant. So the terms are like the monomials. How many monomials are put together? So when you've got 2 monomials put together, it's called a binomial. When you've got 3 monomials put together, added or subtracted together, it's called a trinomial. 4 or more is called a polynomial, but in fact, these are polynomials as well. And you'll see where this is going to play out throughout the rest of the chapter and beyond. Constants are to the degree 0, the power 0. Linear equations, what we've been studying for most of the year, are to the first power, x, 3x minus 2, right? Linear equations. Quadratics, y equals x squared plus 8, right? Something squared. Cubic, something cubed. Quartic to the fourth, quintic to the fifth, and anything beyond that, they say 6th degree, 7th degree, 13th degree, 122nd degree, and beyond. So for example, in these examples here, the degree is third. There are 2 terms, so it's a cubic binomial. Example B, I'm not going to read the whole thing, you can see it, but you can see it has 4 terms, 1, 2, 3, 4, degree to the 6th, so it's a 6th degree polynomial. This last one I'll read, it's negative 2x, 1 degree, 1 term, that makes it a linear monomial. All right, so this is just a little bit of vocabulary, but it's how we communicate to other people what we're really trying to do. So the first one here, let's see, I've got 4 terms raised to the third power, so that would be a, yep, that's right, a cubic polynomial. The second one here is the number 6. It's a constant, right? 1 term, monomial. And last one, oh my gosh, 8th degree trinomial, good gravy. Right? And again, you saw that. I just looked at it and said, oh, 8th degree because of the powers to the 8th. Trinomial, there's 1, 2, 3 terms. Just approaching 9 minutes here. I got to wrap up with one example because the word problems are where life's at. We're talking about dropping lip balm off the Golden Gate Bridge. Shame on that tourist because that's littering and it's going to cause marine debris. But it gives you an equation here. It says the bridge is 220 feet up from the bay. The height of the lip balm at any given time is given by the polynomial negative 16t squared plus 220, where t is time in seconds. So how far above the water will the lip balm be? Well, this is where it really matters, because now we're going to substitute 3 for t and evaluate the equation. So 3 squared is 9 times negative 16, this is a negative number, plus 220, and you end up with 76 feet above the water after 3 seconds. So that's the big idea. These are problems we're actually you're going to work on these together in class. So I'm going to stop there and I'll try to keep each lecture a little bit shorter than this.